in the exam?
I can send the portion of it.
Okay, no problem.
Deleted
You
and
can you
undeleted.
can okay, you can just name the last chapter, means till alternating current, till optics, you can say.
Uh, like
हाँ,
what sir? One
आई
chapter
एम जस्ट
names
सेइंग,
before.
आई एम सेइंग, मैं ये कह रहा हूँ कि जो लास्ट का चैप्टर है वो आप बता दीजिए कि कौन सा आ रहा है, जैसे कि ऑप्टिक्स तक आ रहा है या अल्टरनेटिंग करंट तक आ रहा है।
अच्छा अच्छा ठीक।
ओके, नो प्रॉब्लम, सो आप बाद में बता दीजिए। हेलो निदा।
मैं आपको सेंड कर दूं क्या वो?
ओके, नो नीड ऑफ दैट, आई एम जस्ट आस्किंग। ओके,
ओके।
हेलो निदा। निदा, you were in the last class or not? In the last class you were there? Okay, you were not in that class. So basically in the last class what I have told you. Okay, so have you watched the recorded part of the last class, or I should tell you what I have told in the last class? If no, then you can say no, no problem. Okay, very good. So basically just I am telling once again, I think I have told you the AC generator. So for us, you also focus now. AC generator, very simple, means phenomena of AC generator. AC generator is not simple, but the phenomena is simple. So here you have one armature. Armature means a rectangular coil, you can say, like this. This can be a armature. And there are the field magnets. These are the field magnets. So what is the use of field magnet? We know that magnet produces the magnetic field, so these magnet will produces the magnetic field, and this magnetic field is there. So these are the magnetic field lines. These blue color, this is blue color now. Okay, so this representing the magnetic field line. So basically what is happening, this coil is rotating in the magnetic field. This coil is rotating in the magnetic field, and due to the rotation of the coil, there is a change in the magnetic flux linked with the coil. Remember this point, change in magnetic flux linked with the coil, and according to the Faraday law, whenever there is a change in the magnetic flux linked with the coil, induced EMF will be there in the coil, and due to that induced EMF we will get some current, and here we will get some current with the help of this thing here. These are the slip rings. Okay, these are the brushes, and here, from here we will get the current, and this is our load. Load can be your laptop, load can be your television, load can be LCD or anything load. So now mathematically see, flux, magnetic flux is given by BA cos theta. Theta we can write omega t. I have told you how we can write theta is equal to omega t. Theta is the angular displacement of the coil. The coil is rotating like this, so there will be some angular displacement of the coil. So due to that angular displacement, with respect to time, if we will take, so omega is equal to theta by t. So you can write theta is equal to omega into d. Now what is omega? Omega is the angular velocity, with which the coil is rotating about some axis. This is the axis about which the coil is rotating. This is the axis of rotation. Okay, so from here, this is your phi, magnetic flux. So you can see this is time, and time is changing. Time is changing every time. Okay, time is changing. We know that 1 second, 2 second, time is going. So if time is changing, then you can say your magnetic flux is changing. So magnetic flux is changing. Changing magnetic flux will produce the EMF, and this formula you will use, E is equal to d phi by dt. D phi by dt, this is Faraday's law. d5 by dt when you will do the differentiation. So finally you will get your alternating EMF. Why I am saying alternating? Because this is changing with respect to time. This EMF is changing with respect to time. So this you will get. So finally this will be the maximum value when you will put sine omega t is equal to 1. So finally you will get this equation, E is equal to E max sine omega t. Okay, so this will be your instantaneous EMF at some time. So this is the graph because this thing is in the sine form. So the graph of sine is this. Okay, for one complete cycle I have drawn the graph, and time period T, capital T representing the time period to complete one rotation of the coil. Okay, that is time period. We have done one question. This is very easy question. There is only formula here. Now you should remember what is the equation of alternating EMF. Alternating EMF, okay, is different from direct EMF. Like direct current and alternating current we have. In direct current, there is no change in direction. That current is unidirectional, but the magnitude can change there. But the direction is unidirectional. Here, in this case, we will see, or you can see here. Here, each and every point, the magnitude and the direction is changing. Each and every point. Here, your direction is something else. Here, magnitude is something else. Here, your direction is something else. Your magnitude is something else. Direction is this. Okay, this is representing the direction. So, okay, here the direction actually is same, but the magnitude is different. But when you come from this region to this region, here your direction will be reversed. I have told you in the first class. So equation of EMF you should know, E equal to E naught sine omega t. After that I have calculated the average value, because if something is changing with time, so we will calculate the average value. If something is changing with time, so we cannot get the suppose if something is changing with time, means after 5 seconds the value is something, after 6 seconds the value is something. As I am saying that, tell me what will be the EMF between 0 to 5 seconds. So we cannot tell because that thing is changing with time. So in that case, we will calculate the average value. So average value, uh, for the average value, this is the thing I think I have to tell you once again. Suppose if you have a function, y is equal to, if you have a function y is equal to fx, what is the meaning of that? This y is changing with respect to x. For example, you can take an example also. Y is equal to 3x square plus 5x plus 2. So this is in the form, this y is in the form of x. Means this y is changing when x will have some different values. So this is the, so for that case, if you want to calculate the average value of y, average value of y can be written like this. According to NCERT, the average value is written like this. I write the average value y average simply. This will be given by, we know that the average, suppose I have given three numbers 2, 4 and 6. I told you that calculate that the average of three numbers. You can easily calculate, you will add three numbers and divide it by 3. But here the value, this function is changing. So what you will do the integration. Suppose I am saying that calculate the average value of y from 0 to x is equal to 0 to x is equal to 5. Okay, x is equal to 0 to x is equal to 5. So you will write y into dx divided by integration of dx 0 to 5. So this thing you should know, and with the help of this you can calculate the average value here. Accordingly you will You want to calculate the average value of EMF for full cycle. Okay, so you can calculate easily. Okay, just note down this point. Note down this point, then we will calculate the root mean square value of the EMF or current. That is most important thing. Root mean square value of alternating EMF. Note down this. Not this. Not this. Only this part.
Done, sir.
Hmm. Okay. Okay, good. So now we will calculate the RMS value. Okay, now focus. Because in RMS value, there will be a use of some formula and then integration then. Okay. So note point, if you want to calculate the RMS value of some function, and that function is again is a function, y is a function of x. If you want to calculate the RMS value, root mean square, RMS value, RMS, R means root, M means mean, mean means average, mean means average, S for square. So what you will do now? You will move in this way. First you will do the square of the values, then you will take the mean, then you will take the root. Okay, so I want to find the RMS value of y for some limit I will. So first what you will do, you will do the square of y. So write y square first. Now take the average. Now take the under root. So you know what is y? Y is fx square. So accordingly, what we will do now? We now calculate the RMS value of EMF, alternating EMF. You can calculate the RMS value of velocity, anything that is changing with time. You can calculate the root mean square value of velocity. You can calculate root mean square value. There is a one chapter in 11th class, kinetic theory of gases. There is RMS value, velocity, root mean square value. So RMS value of alternating EMF. Alternating EMF. Okay, for full cycle. For full cycle means for 0 to t time. For full cycle. Simple. What you have to do? You will write the equation of EMF. Equation of not EMF. Equation of alternating EMF. You should know. Equation of alternating EMF. We know that the alternating EMF is given by E is equal to E naught sine omega t. This is the equation. So we have to calculate ERMS. For ERMS, first what we will do? We will do the square, then we will take the average, then we will take the under root. So under root I can write like this. This E, I can write this E square means this E naught square, and this is sine square omega t. This is sine square omega t. And for under root na I can write half na. I can write half. Under root means the power half. Okay. Okay. Now average of E, we will calculate the average of this E square. So average of this E square can be calculated E square dt, okay, E square dt divided by integration of dt, and here also you will put integration, and you are calculating this RMS value for the full cycle, means 0 to t time, 0 to t time, for 0 to t time you are calculating RMS value. Okay, we can remove this for a moment. This thing is clear, Fawaz? This thing.
Sir, what is the DT under it? What
Actually,
is it mean?
dt, full cycle I have written, no, full cycle. Full cycle means the time taken by the coil to complete one rotation, and for completing one rotation by the coil, time taken is capital T. Means we have to calculate the root mean square value. We have to calculate the root mean square value of EMF for 0 to t time, and dt is representing the small interval of time. I have told you we calculate the average value like this. Here I have told you, I think, here this is the, here I have written dx now, here I have
Yes,
written
sir, yes,
dx,
sir.
but there I will write dt, there I will write dt. Okay, just I am telling once again, otherwise there will be problem.
Sir, I got it,
Oh, got it now?
sir.
Okay, but I do not got it. Hmm. So there is another method. Hmm, average value na, so we have to write here, we know that current is equal to dq by dt. We know that current is equal to dq by dt, and this is the instantaneous current now. This is the instantaneous current, and for average current, what you will write? Average current you will write charge divided by time. There will be some finite charge for some finite time. Okay, so here what you will do now? Here what you will do? You want this average. So from here, from this equation, you can write this equation: dq is equal to I into dt. We can write now. If we will do the integration both sides, then here we will get q, and here we will get I into dt. But one thing you should know, this dt, integration of dt can be written as t, because when you will add a small time, then you will get this t. So now I average, oh, just a minute. I average is equal to q. Q is I of dt divided by dt. Instead of t, we have put this. Instead of this q, I have this value. Now, accordingly, from where to where you want to calculate the average? Suppose you want to calculate the average from 0 to t time, then you put the limit 0 to t. Got it? Now,
Yes, sir, got it.
this is another method. But okay. Hmm. So basically, we have to calculate the RMS value of alternating EMF. Here I have calculated the uh, average value of current. In the same way, you can calculate the value of the EMF also. Okay. So here, first we should know the equation of EMF. E is equal to E naught sine omega t. E is equal to E naught sine omega t. You have to calculate ERMS. So first you will do the square, then you will do, then you will take mean. Mean means like this, then you will take the under root. Okay, so under root, and this average value of e square you want to find. Average value of e square. What is this? This thing is average value of e square. So average value of e square means e square into dt. Here this is dt, and for full cycle you are calculating, na? So you will take the limit 0 to t. 0 to t. Now put e square. Now what is e square? E square is e naught square sine square omega t. Put the value. So this under root, for under root I can write power 1 by 2. So this is integration of e square means this e naught square sine omega t sine square omega t into dt. And here is your this 0 to t dt. I have told you 0 to t dt will become t minus 0. Here. Got it now? This thing, integration of dt is t. When you will put the limit, you will get capital T. Okay, t minus 0, you will get t. Okay, fine. So here is your dt na, so here you will write t, and you will take the half power of this. Now, okay, now here limit is 0 to t we have. Now this E naught is the peak value of EMF. I have already written here E naught is the peak value or the maximum value of the alternating EMF. So this is the constant value. So you can take this out of the integration. So now you have to integrate 0 to t sine square omega t. This you have to integrate. And here is t. This t will be in the denominator. And this whole thing have power half. Now the thing starts. How you will integrate sine square omega t? Sine square omega t. Actually, sine square omega t can be written as 1 minus cos 2 omega t divided by 2. This is the trigonometric formula. This is the formula. See, if you have cos 2 theta, then you can write 1 minus 2 sine square theta, and if you have cos theta, then this can be written as 2 cos square theta minus 1. This is trigonometry. Okay. This formula you should know. So here I am writing. This thing is here. A corner. Okay. So basically, we can shift this thing here, this side. Okay. Now, okay. So here I have shifted here. So now we can write this E naught square divided by T and integration of 0 to capital T. This sine square omega t can be written as 1 minus cos 2 omega t by 2. 1 minus cos 2 omega t divided by 2. And this is dt, and this whole power half. Now, further we will solve it. This is E0 divided by E0 square divided by T, and you can write this thing. This thing you can write this. This can be written as 1 by 2 integration of 1 by 2 dt, 1 by 2 0 to 2 t dt, minus you can write half, or it is better to take this half common. It is better to take this 2 is can be taken out of the integration now. So out of the integration you can take. So this 2 will be here, not here. 2 will be in the denominator. Okay, this 2 will be in the denominator. Beta, are you getting or not? Fawaz and Hiba, what is your name?
Yes, sir.
Nida, sorry. Nida. Are you getting? Otherwise,
Yes, sir. It's clear.
okay, good. Because this is the integration, so I think there may be a problem, but I think I have told you the integration, but here also I have told you how to put the values. So now see, there are different ways to calculate the thing. Okay, I have just taken the common this out of the integration. So now here what we have, this dt multiplies this is 1. So this will be written as 0 to
सर
t and huh
सर
yes.
अगर इंटीग्रेशन हो गया तो वो इंटीग्रल का साइन क्यों अभी भी है?
अभी इंटीग्रेशन हुआ ही नहीं है, अभी तो इंटीग्रेशन होगा।
नहीं, वो हो गया साइन स्क्वायर ओमेगा टी का।
नहीं बेटा, वो साइन स्क्वायर टी का मैंने इंटीग्रेशन नहीं करा था। यहाँ पर ना जो ये चीज आप बोल रहे हो ना, वो
हाँ,
मैंने इस चीज को इस फॉर्म में कन्वर्ट किया है। इंटीग्रेशन तो ये है अभी
उसका
अपना,
फॉर्मूला लिख।
फॉर्मूला लिखा है वो मैंने। ओके,
ओके,
आई हैव रिटन द फॉर्मूला, टिल नाउ आई हैव नॉट डन द इंटीग्रेशन। So when we will do the integration, then sign of the integration will be removed and we will apply the limits. Okay, now see, this dt will be here and minus integration of 0 to t integration of cos 2 omega t. Okay, cos 2 omega t. So you can now close it and this whole thing have the power 1 by 2. This derivation is a bit lengthy, but what we can do, this is e naught square divided by 2t. Okay, e naught square by 2t. Now see this part, this is dt, 0 to t dt I have written here. 0 to t dt is t, capital T. Here you will get capital T, and what we will get here, integration of cos 2 omega t will be sin omega t, sin 2 omega t, and this 2 omega will be in the denominator. If you are doing the integration of suppose sin of 5t dt, so what will happen here, it will be minus cos of 5t and this 5 will be in the denominator. Okay, so now integrate this will be the sin 2 omega t divided by 2 omega, and you will apply the limit 0 to t. Okay, you will apply the limit 0 to t and this whole power have, this whole thing have the power 1 by 2. Okay, so now this is e naught square divided by 2t and this is t minus, now this 1 by 2 omega can be out, so now you will put the value of upper limit in this. So you will write here sine 2, instead of omega you can write 2 pi by t, and instead of this small t, you will put the upper limit. So this is t minus, this is 0, so this will become sine of 0 degree. This is this and this is whole power 1 by 2. Okay, now This is written like this, and this is here t. This is minus 1 upon 2 omega. Now see here, this t and t will be cancelled. Sine of 4 pi, sine of any pi equal to 0. Sine of 4 pi, 5 pi, 6 pi, 7 pi, 8 pi, 9 pi equal to 0. Sine of any pi equal to 0. So this will be 0, this will be 0. Finally, this is 1 bar 2. So this term will be 0, na? Whole term will be 0. So what do you have? You have this thing, na? This t and t will be cancelled out. Okay, so finally you will have E naught square by 2 to the power 1 by 2. So you can write this as E naught divided by root 2. For simple, this is your ERMS for full cycle. ERMS for full cycle. Okay. So you can copy from here. Hamza, hello Hamza, are you there?
Yes, sir.
You are late today?
Yes, sir. I forgot about the class.
Okay, no problem. Just write down. We were
Yes.
calculating the root mean square value. Beta, you should know na integration means in between. I am just telling you again and again that integration. So write down uh, those things with some separate space. Okay, in separate space you can write the integration. Otherwise, definitely you will confuse again and again, again and again. What is the integration of sine? What is the integration of cos? Okay. So Fawaz, completed. Should I scroll down?
Yes, sir.
Okay, now write
Yes,
down
sir.
this, and I am just zooming it in so that you can get it. Write down this. Actually, this chapter you are studying na alternating current. This chapter will be studied when, if you will go in the engineering. In the first semester, there is one chapter, basics of electrical engineering. So there you will study these things in detail. This very small portion. This is a part of the electrical engineering.
Sir, can you scroll little down?
Little down.
Yes.
You are very fast. Very nice. Yeah. Oh, Fawaz, have you seen the Flash?
Sir, yes, sir.
No problem.
Uh,
Are you writing or taking the screenshot?
no, sir, I'm writing.
So how can you write so fast?
Sir, I was writing with you only.
Okay, that is why you are writing.
Yes, sir.
Okay, just write down. Then we will solve one question. There is one person whose name is Flash. Okay. Okay, good. So now we will discuss one question. Earlier in the current electricity, remember you have different type of current and EMF. Here you have different type of current and EMF. There the direction of the current is same. Always. There is no change in the direction. There is no negative and positive. That current is okay. That current is, there is no change in the direction there. But here you will see the current and the EMF are the function of sine and cos. You will see here. So sine and cos changes with time, direction and magnitude. Now there is one question, very easy question. Question is equation of alternating EMF is given, that is E is equal to 10 sine 314 into T. This is the equation of alternating EMF. They are asking calculate number 1 peak value. Number second, they are asking calculate the average value for full cycle. After that, they are asking in third part average value for half cycle. Average value for half cycle. In fourth part, they are asking angular frequency. In fifth part, they are asking RMS value, means root mean square value. RMS value of EMF, or you can say alternating EMF. So in sixth part, they are asking EMF at T is equal to pi divided by 6 into 314 second. Okay, one by one I am solving. So we have this equation of EMF, E is equal to 10 sine 314 into T. We will compare this equation with the standard EMF equation. E is equal to E naught sine omega T. Now when you will compare the equation number 1 and suppose this is equation number 2, when you will compare na, so what you will get, peak value of EMF you will get 10. What is the omega you will get? 314 and unit of omega is radian per second. This you will get. So first question is peak value. Peak value is E naught and this is 10 volts. Second answer number second. They are asking average value for full cycle. What is the average value for full cycle? For alternating EMF, always the average value for full cycle is equal to 0. So average value for full cycle, you can write average in this way, or you can write average in this way, or you can write average in this way, and all are equal to 0. Third part, average value for full cycle. Just average value for full cycle. So average value for full cycle, you can write that EM. EM is the average value for full cycle, that is given by 2 into peak value divided by pi. Okay, so accordingly you can calculate. You have 2, you have E naught, that is 10, you have pi. This will be your answer. Fourth part, they are asking in fourth
Sir,
part.
third one was half cycle.
Yeah, this is for half cycle in third part. This is in third part. We are calculating for half cycle. For half cycle, I have derived this equation for half cycle. Average value of alternating EMF for half cycle. See the value 2 E naught divided by pi. Got it now?
Okay.
No problem. So in the fourth part, we have to calculate angular frequency. Angular frequency means omega. Omega is known as the angular frequency. Omega is 314 radian per second. Omega is 314 radian, which is the angular frequency. RMS value, just calculated the formula of RMS value. ERMS. ERMS is peak value divided by root 2. Okay, what is the peak value? 10 divided by root 2. And this will be in volts. Sixth part, they are asking, time is given. Time is given, t is equal to pi divided by 6 into 314 second. And at this time, we will calculate what will be the value of this EMF. So we have this EMF equation. So we will put the value of time simply and we will get the answer. So now put the value. This is 10 sine, this is 314. What is time? Time is given as pi divided by 6 into 314. So this 314 is gone with 314. What we will have? Sine pi by 6. What is the value of sine pi by 6? 1 by 2. You will get 5 volts. Okay, beta. Write down. Very easy question. You can get this question in exam also. Not this question, this type of question. Okay, write down. There will be one term here, phasor diagram. Okay, phasor diagram. We will discuss. Okay, done. Very good. Okay, okay. Fine. Fawaz and means what is your name? Hamza, are you taking the screenshots or not? Hamza, take the screenshot also, okay? And Fawaz completed.
Yes, sir.
Okay. So now this is all about the EMF. Now, if current is there, alternating current is there, na? So all the things will remain same. You will write equation for alternating current. Equation. I can write AC, na? Alternating current. Equation for alternating current. What is AC current and what is AC? Fawaz, if I will write equation of AC current. Okay, equation for alternating current. Okay, so you can write here alternating current. Alternating current. So alternating current, I will write with I. I is equal to I naught sine omega t. This is the equation of alternating current. And what is I? Again, I is the instantaneous value. I is the instantaneous value, means value of the current in the circuit at an instant of time. What is I naught? Peak value, or you can say maximum value. Peak value or maximum value. What is omega? Omega is again angular frequency. Omega is again angular frequency. We all know what is small t, time. Now if you want to calculate the average value of current for full cycle, then you will get 0, because we have already calculated the average value of EMF for full cycle. So average value of alternating EMF and alternating current for full cycle is equal to 0. So you can write here, first thing, average value of current, or you can write now here I, because here I is representing here, okay? I is represented here. Average value of I for full cycle is 0. Now, if you are calculating average value of I for half cycle, that you will get same as that of same as that of EMF. Okay, same as that of EMF, because for full cycle E average is also equal to 0. For half cycle E average is also equal to 2 E naught by pi, and this thing is given by, when you will divide 2 by pi, you will get 0. This you will get 0.637 of I naught. This also you will get 0.637 of I naught. If you will calculate the root mean square value for current, this time RMS value for current for full cycle, again you will get the same value as that of EMF. What is the value of EMF? ERMS E naught by root 2. So here you will get IRMS is equal to I naught by root 2. I naught is the maximum current. What is this? This is your average value. This is your I average. Okay. Now we will have uh, circuits in AC. Earlier we have discussed the circuits in DC. Now we will discuss the circuits in AC. Okay, circuits in AC we will discuss. Mm, just a minute. Just a minute. We will discuss the circuit theory. Circuit theory means you will have the alternating source with resistance, with capacitance, with inductor. So circuit theory. Circuit theory. So first circuit is pure resistive circuit. Pure resistive circuit. Pure resistive circuit means you have a resistor, and with this resistors an AC source is connected. An AC source, AC source is connected. Earlier we have studied this type of circuits. DC source is there. This is the DC source, and this is your AC source. Okay, so this AC source is there, and we know the voltage or EMF is V is equal to V naught sine omega t. Okay, I have written the equation in form of EMF now. E is equal to E naught sine omega t earlier. So now I am changing this equation. E I am changing with V, and E naught I am changing with V naught. Now this is the EMF, and this I am writing the equation in terms of potential. V is equal to V naught sine omega t. Okay, so now as we know that there will be the current in this circuit because this is the AC source. Due to the AC source and this resistance is R, there will be the current, but we know that the direction of current is changing again and again. So just I am supposing at some point of time the direction of the current here is in this direction. Direction of current here is in this direction. Okay, so anyone of you know the Kirchhoff's law, Kirchhoff's voltage law? Summation of the voltage along the circuit is equal to 0. Okay, no problem. I am telling. So what you will do now? Here you will apply the Kirchhoff's law in this loop. So you will take this voltage, that is V. Okay, and here current is going in this direction means current is going toward the decreasing potential, so means potential is decreasing, so means this will be minus IR, and this is equal to 0. So from here you will get V is equal to IR, and from here you can calculate I is equal to V by R. And what is your V? V naught sine omega t by R. So your this V naught by R, na, this V naught by R is equal to I naught. I is equal to V naught by R. I naught is equal to V naught by R. So you can write the equation of current here. I is equal to I naught sine of omega t. You can write. Now you have the voltage equation. You have the current equation. Now there is a term here. There is a term. Phase difference. There is a term phase difference. Okay, so what is this? This V naught is the peak value, or I naught is the peak value of current. V naught is the peak value of voltage. So here is a term phase difference. Phase difference, I will represent this phase difference with some phi. So phase difference is mod of phase of voltage minus phase of current. What is the meaning of phase? Phase means the angle with sign. Whatever will be the angle with sign will be the phase of the voltage. So here the phase of the voltage will be omega t. Here the phase of the current will be omega t. Okay, so what will be the phase difference? Phi. Omega t minus omega t. Phase difference is equal to 0. Phase difference between the current and the voltage in the resistive circuit is equal to 0. Now we will show this on the phasor diagram. Phasor diagram. This is new thing for you. So see how we will draw the phasor diagram. We will draw two axes like x-axis and y-axis we draw now for position time graph, for velocity time graph. So we will draw this. So this axis I have drawn. What I will do now here. I have two equations. V is equal to V naught sine omega t, and I have I is equal to I naught sine omega t. So first I will plot this V. So see how I will plot. So I am just plotting it like this. From this point I am taking this, okay, and this is the arrow. The length of the arrow, this length of the arrow is representing the peak value of voltage. Okay, the length, and this V is making an angle of omega t with this axis, so this will be omega t with this axis. With this axis, this angle is omega t, and this is V naught. And when you will take the projection of this V naught on y-axis, on this axis, so what you will get? What you will get? You will get V naught sine omega t. So this thing will be V naught sine omega t. This projection will be V naught sine omega t, means this projection will give you the instantaneous value. Instantaneous value. Now we will draw the phasor diagram for the current. Phasor diagram for the current. What is the current? I naught is equal to V naught divided by R, means the value of the current is somewhat less than of V naught, means the length of the arrow of the current will be lesser. So this will be your I naught, and here also when you will project it on this axis, you will get the instantaneous value of current. Here you will get instantaneous value of current. I am writing here, suppose this point O and this point A and this point V. So you can write your OB is equal to, length of OB is equal to magnitude of this sine omega t, and magnitude of OA is equal to, you will get I naught sine. So in this way we can just draw the phasor diagram. And one thing more, current and voltage are in same phase. So simply for solving the question, we can use this. Your voltage is this is voltage and this is your current. Both are in same phase. Both are in same phase. Okay, so here what I have told you, length of the arrow, will represent the peak value. So length of this green color arrow is representing the peak value of this voltage, and length of this arrow, this yellow color head, okay, is representing the peak value of current. And you can write here projection on y-axis. This is your y-axis, suppose this is your x-axis. Projection on y-axis will give you instantaneous value. Instantaneous value of either current or either voltage, depending upon to what thing you are taking the projection, of what thing you are taking the projection. Now you can draw it with a different type of diagram. I will say the wave diagram. Wave diagram. Wave diagram means you have to draw the sine curve like this, and just wait a minute. Okay, now we will draw the wave diagram for V is equal to V naught sine omega t, and I is equal to I naught sine of omega t. So for okay, this is for the voltage. This graph is representing the voltage, and when you will draw for the current, so this will be like this. You should know what is the time here, here. So this will be like this. Just a minute. Like this, and it will be like this. Okay, why this yellow color diagram? This yellow color diagram is for voltage. This yellow color diagram is for V, and this green color diagram, is for current, because the magnitude of the current is somewhat less than the voltage. Okay, so we will put the value of time here. What are the time here? Here is 0, here is t by 2. Okay, here is t by 2. No, not t by 2, t by 4 is here. Here is t by 4 time, T/4 of time period here is uh, T/2. Here is 3T/2 at this point. Here is T. Okay. Okay, note down. Okay. Remember, here is the AC source and there is a resistance here with AC source. Okay. Was done.
हाँ सर.
Hamza, take the screenshots also.
Done.
Okay, good. Okay. Oh, this is 3t by 4, not 2. 3t by 4. Draw the wave diagram, this diagram properly. Okay.
सर लास्ट टाइम आपने 3t by 2 ही लिखा था.
हाँ, मैंने 3t by 2 लिखा था, but half of t and this when you will take ना, you will get 3t by 4.
तो लास्ट टाइम का वो सही करना है.
हाँ, 3t by 4 करना है. Oh, actually, after this, in the next class, I will discuss the inductive circuit. There will be one inductor, and that inductor will be connected with some AC source. But before that, I want to discuss some integration, because I know that, or I feel that your integration is not that okay. One or two question I will discuss. Okay, done all of you?
हाँ यस सर.
Okay. Nida, completed? Okay, fine. Very good. So now we will discuss some basic integration. So suppose if it is written like this, sine of x into dx, or you can take t, sine t dt. Then the integration of this minus cos t, and there will be some integration constant. But if you are taking with the limits, then there will be no constant. And if you are suppose doing the integration from 0, t is equal to 0 to t is equal to 5 second, then take here 0 to t equal to pi by 2, t equal to pi by 2. Okay, so what you will do, you will apply the limit 0 to pi by 2. So first you will put this limit in t, then minus you will put this limit in t. So how you will do, you can take minus out you have taken. Now you can put cos of pi by 2 minus cos of 0. Okay, so this will become minus cos pi by 2. You should know cos pi by 2 is 0. Cos pi by 2 means cos 90. Pi by 2 means 90 degree. Pi by 2 is in radian, This pi by 2 is in radian. Okay, so this is equal to 0. So here will be 0 and cos 0 is equal to 1. Cos 0 is equal to 1. 0 degree is equal to 1. So you will get this. So now what you will get finally 1. Suppose this is the question. 0 to pi by 2 sine of not sine this time. We will discuss only differentiation integration of sine and cos only this time. 0 to t is equal to pi by 2, t equal to 0 to t equal to pi by 2 cos 2t and dt. This integration we have to do. So what we will do, this type of integration, first we will see what is the integration of cos. So integration of cos is sine. Integration of cos is sine, and we will write the angle. The angle is with cos. This is sine 2t. Then this here is 2 into t, na? Then this is 2 into t. Now you will what you will do? This 2 na from t, coefficient of t you will take, coefficient of t you will take in the denominator, and then you will apply the limits 0 to pi by 2. Now this half you can take out of the limit, then you can put the value. So this will be sine 2 into pi by 2 minus sine 2 into 0. So this will become half, 2 into 2 cancel, so this will be 0. Sine pi, sine of any pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi is equal to 0. And his sine 0 is 0. So your answer will be 0. All
Sir,
of you,
sir,
Fawaz?
what is this?
What
is this wave diagram or
This, na? This you are saying.
this
No,
whole
no, no.
thing?
This thing. What are you saying?
No, sir. This derivation. This
Actually, no.
calculation.
This calculation, I am just integrating this cos function. I am just telling you how to integrate cos and sine. This is This is just a general thing I am telling you. Okay, this is not any kind of topic or other thing. No, this is for your understanding. Means you have seen that the integration we have used many times. Okay.
Yeah.
So there is one question for you. Integration of 0 to t is equal to pi by 2 sine of not 5t, sine of 2t. Can you do this? Anyone try this question? Okay. So first integration of sine 2t is minus cos 2t. This 2 will be in the denominator and you will apply the limit 0 to pi by 2. Here this minus 1 by 2 will you can take out. Now you will apply the limit. This is cos 2 into pi by 2. Okay, minus this will become cos of 0. So this will become minus 1 by 2. This will become cos pi. Cos pi is minus 1. Cos 0 is again minus 1. So you will get minus 1 by 2 into minus 2. So you will get 1. Okay, you can note down these questions. These questions may help you. Note down. Just a minute. Okay, note down this. Okay, done. Very good. Note down this part, last part. Hamza, you take the screenshot. Okay, note down this and we will meet in the next class.